Hello? Hello? Audible, na?
Yes, ma'am.
Yes, ma'am,
Okay,
it's
okay,
audible.
okay, okay. So last day I asked that whether the current rating of a 200-watt incandescent bulb and a 100-watt incandescent bulb will be same or different. So will you answer, anyone? The question was that efficiency of the 200 bulb was more than the 100-watt bulb, right? কি বলবে কেউ? খুব সিম্পল একটা কোশ্চেন, না? Forget about bulb, just two electrical devices, passive device, 200 watt and 100 watt. So what about the current rating? কি জয়, তাবিদ, আনন্দ, সুব্রত আছো এখানে? পিয়ুষ, হিমাদ্রি।
Yes, ma'am.
So what do you think? কিছু একটা বলো না, মানে থার্ড ইয়ারে পড়ো, এটা এত তো কঠিন কোশ্চেন নয়। বাকিরা কেউ? Three illumination law, that how the light will be distributed and will reduce with the distance from any source. So these three law were, these were inverse square law, the inverse square cosine law, and Lambert's inverse square cosine cube law. So square law was that when the point is just below the source, it was normal to the light ray. So then the light or illumination, it will vary directly proportional with the luminous intensity and square of the distance from the source to the point, right? Then the next one was cosine.
ম্যাম
Yes, yes.
ম্যাম আপনি মনে হয় স্ক্রিনটা শেয়ার করেননি।
Oh, okay, okay, okay. Okay, so the third one was the same, just here we express the height, the distance in terms of the mounting height of the source. So it was I cos cube theta by h square. So next is the Lambert's cosine law. So this law states that the illuminance on any surface, it varies as the cosine of the angle. Okay, not this. Next one is perfect diffusion and Lambert's cosine law. So as we know that if we have any source, then the illuminance value at any point normal to the source, it will be I by d square. Otherwise, it will be I cos theta by d square, right? So according to this Lambert's cosine law, any perfectly diffusing sphere is one which emits or reflects luminous flux in such a way that it has the same luminance regardless of viewing angle. Such a surface is called Lambertian surface. So Lambertian surface, it will emit same amount of luminous flux in such a way that it will have the luminance regardless of viewing angle. I don't know whether you remember the luminous flux or luminance, but just for your information, luminous flux is the, just a second. The luminous flux is the total light output of any source. So the light will be distributed in all the directions such a way that the luminance will be same whatever be the viewing angle. So we know that luminance is candela per meter square, luminous intensity per meter square. How much light is coming to any particular direction per unit solid angle per unit area, right? So the light will be distributed in such a way that it will be same bright to the to the eye of the observer. That means the luminance will be same. The parameter is luminance. So regardless of viewing angle, it will be same. That means if this is my Lambertian surface, around this sphere, everywhere luminance will be same. And at this point, intensity will be maximum I max. Other than this, any point, it will be I max cos theta. So intensity will be different at different points, but luminance will be same. So as we know, L is I by A, intensity per area, candela per meter square. So it's I theta by projected area. So I theta by S cos theta. So at theta 0, L is I 0 by S. Or at any other angle, it will be I theta by S cos theta. So for any Lambertian surface, this I theta by S cos theta, this will be same. So it will be I 0 by S. So we can write that this S will be cancelled. So we can write that I theta will be I 0 cos theta. Okay. That means this profile will be sphere. If this is a Lambertian source, at this point I will be maximum, or any other point I will be I max cos theta, or the luminance will be same regardless of viewing angle. Okay. Okay, so example of Lambert's cosine law is a good quality whitewash wall. That means it will reflect the light equally in all the directions. So it reflects or emits equal luminance in every direction. We know that luminance is intensity per unit area, because both intensity and apparent area follow the cosine law. They remain in proportion to each other. So luminance will remain constant. Is this one okay? So we will call any source as Lambertian surface or Lambertian source if it's emit luminous flux in such a way that the luminance will be same regardless the viewing angle. Okay. Then this is a relationship between light output and light intensity for flat diffuser. So here we have a flat diffusing surface, this S. We have to find the relation between light output and light intensity for this diffuser. That means we have a source here. It will emit light in this hemisphere only. Down hemisphere it is 0 ache. So it will emit pi lumens in the upper hemisphere. Okay. So we have to find the relation between the light output phi and the intensity of the light source. So we know that E is I by R square, right? Then I by R square into A, so we will get the total luminous flux. Total luminous flux is illuminance into area, right? How much light is coming to any surface into area, so we will get the total luminous flux. So we have to compute illuminance. Okay, illuminance we can find from the Lambda's cosine law, that is I cos theta by d square. So if this is my source, we want to find the illuminance on any small area, received light at any small area. So here a small ring is considered with r delta theta. What is r? R is the radius of this hemisphere, and a small ring, this one, this small ring, this width is the small r, radius r. So what is the area of the small ring? Width, which is r theta into 2 pi r. What is 2 pi r? Eta hoche r. This radius is r. Okay. So this one is 2 pi r. So if you express the small r in terms of capital R, this is small r, this is capital R. So if you express the r small r in terms of the total radius, so it will be r sine theta. So we can get this one. So area of the ring is this. So if we know the area of the ring, we can find the illuminance received on that ring from this particular source S. That is I cos theta by d square. Now theta is 0 here, so this is I by r square. I by r square means I theta by r square into this area what we have calculated before. This is the lumen received on the small ring. So now if we want to find the lumen on the total hemisphere, so you have to consider the limit from 0 to pi by 2. So then this will be the total limit. So if you calculate this, we will get pi I0. That means if the intensity of this source is I0, the total luminous flux will be pi into I0. So for this flat diffuser, lumen will be pi into maximum intensity. Instead of flat diffuser, এটা যদি round diffuser হয়, it will be 4 pi I. যদি একটা tubular diffuser হয়, for example tube light, so the total lumen will be pi square into maximum intensity, like that. Okay. Any question? Anyone?
Yeah.
Any question? Huh.
No, ma'am, no, ma'am.
Okay. Okay, so then the next topic is luminaires. So, so far we have discussed the few laws of electromagnetic radiation, the black body laws, then thermal radiator and black body, some photometric and radiometric parameters, the laws of illumination. Next topic is the photometry or measurement of light and lamps and luminaires. So before going into the photometry, we need to discuss few lamps and luminaires. So lamps we all know that is the source of the light. There are different type of lamps we will see later, like There is some incandescent source where we can get light by heating. There are few discharge lamps, like where we can get the light from electrical discharge of gas, like fluorescent tube light, sodium vapor, CFL, etc. Then there are some solid state lighting like LED, light emitting diode, or OLED, etc. So, what is Luminaire? Luminaire is that lighting equipment which contains the light source, electrical components, and light control devices. Like if you use the bare lamp with a holder, so that is only the bare lamp. But if the lamp is placed within any kind of lighting equipment, like if you see the street lights, though there you cannot see the bare lamp. There is a cover over the lamp, so that is the luminaire. It contains the lamp, the electrical components like ballast, discharge, ballast, controller, driver, etc., and the light control devices, if any. So it contains the lighting fix. It is the luminaire or the lighting fixture. It contains the lamp socket to hold the lamp, the ballast, which is required for the discharge lamps, some kind of reflective material to control the light rays in different directions, then lens, refractor, louver to distribute the light as per our requirement, and housing to support and attach the luminaire. So these are different kind of luminaires, some indoor, some outdoor. Okay. The functions are to provide necessary electrical power to the lamp and other electrical gears such as ballast, driver. It control, distribute and direct the light in the desired direction. If you use the bare lamp, of course the light output will be according to the uh, type of the bulb, type of the glass. But if you use the luminaire along with this, so there are some optics with the luminaire. So it will change the directions of the light depending upon the reflective material, the lens, etc. It also protect the lamp and optics from dust and water. It also used to maintain ambient temperature required for the lamp. So these are few indoor luminaires. The tube lights are used inside this. You can see one uh, street lights here with a sodium vapor lamp. This one is also another outdoor luminaire with maybe sodium vapor or metal halide source. So how do you define the efficiency of any luminaire? Efficiency we know is the output by input. So here output is the total light output which is coming from the luminaire. And what is the input? Input is the total individual light output without luminaires. Means what is the light output from the bare lamp. So if you use only one lamp with the luminaire, it will be the light output from that single lamp. If you use more than one lamp, so you have to add them. Okay, so this is called light output ratio. যেরকম আমরা ল্যাম্পের এফিসিয়েন্সিকে বলি efficacy, this one is known as light output ratio. It is the ratio of the light output coming from the luminaire to the total light output from the bare lamps. Okay. So it includes both the downward as well as upward light. So downward light is important from the utilization of the light. So মানে যদি লাইটটা উপরের দিকেই যায়, so that is the total overstage. So that is called upward light output ratio or ULOR. And if it is coming towards the down hemisphere, this is called the DLOR or downward light output ratio. So the DLOR and ULOR, if you add them, we will get the total light output ratio. Okay. So DLOR is in the down hemisphere and ULOR in the upper hemisphere. So depending upon this light distribution, there are different kind of lighting schemes like direct lighting, indirect, semi-direct, semi-indirect, general, etc. So what is direct lighting? If the light is directly coming towards the uh, workspace or towards the down hemisphere, that is called the direct lighting. So almost 90 to 100% light directly falls on the object. 90 to 100% is in the downward. So you can say that DLOR is 90% and ULOR is 0 to 10%. Okay, so the light is made to fall upon the surface with the help of deep reflectors. Wherever be the light is going inside the luminaire, by using the reflector, it will come to the downward side. So normally these are used in industries and commercial lighting. So this is most efficient, but it causes glare and shadows. Why glare? Because glare means some discomfort in our eyes due to the presence of the light. When directly jo chokhe jehetu asche, so it can cause some glare. Okay. So you can see three tube lights are placed inside this luminaire. This one is LED. Next is just the opposite, indirect lighting. Here, instead of 90 to 100 in the down hemisphere, 90 to 100 will go to the upward direction and 0 to 10 will be the downward direction. So 90% of light directed upwards by using diffusing reflector. So here the ceiling acts as a source of light and this light is uniformly distributed over the surface and glare is reduced to minimum. It provides shadowless illumination which is useful for drawing office and composing rooms. So you'll ask me that if 90 to 100% is going towards the ceiling, so it will be complete wastage, no? So why will use this even? The fact is that although 90 to 100 is going towards the upper direction, but there will be some reflection from that upper side. Then it will come towards the downward side. So instead of a very high bright source, you will see some soothing light actually. Okay, মানে ওখানে যেরকম directly চোখে আসছিল, instead of that, it will at first go towards the upward direction. Then by reflection from that ceiling or the upper portion of the luminaire, it will come towards our workspace. Okay, so the light is uniformly distributed. It's not uh, like a very high bright source. Okay, so more uniform distribution will be there. So although it's a tube light, you cannot see the light from the outside because the light is focused in the upward direction. Then from that upper portion of the luminaire, it will reflect back towards the downside. Okay. Next is semi-direct. These are just in between this direct and indirect. Semi-direct, semi-indirect, and general. So semi-direct, 60 to 90 downward, 10 to 40 upward. Direct indirect is 40 to 60. General diffuse 60 to 40. Semi-indirect 60 to 90. So in between this direct and indirect, all others are depending upon our requirement. This one is direct, you can see. So if you forget the name, these are called polar curve or light distribution curve. So these two axes, one is that it's, I mean, this part shows the down hemisphere, the upper part is just above the luminaire. That means my source is located at 0, 0, 0. Here the source is located, the point source. This is the point source. Okay. So you can see for direct, this is the light is distributed like this. For semi-indirect, 10 to 40 in the upward, 90 to 60 in the downward. Direct indirect, it's almost 50-50. General diffuse, it's same. General diffuse means the light will be distributed uniformly in the entire space. Semi-indirect, just opposite to the semi-direct, 10 to 40 in the downward, 60 to 90 in the upward. Indirect, 90 to 100 in the upward direction. Okay. Just 2 minutes, I'm coming. So is this okay or any question? Anyone? আনন্দ যতীন্দ্র আছো তোমরা?
হ্যাঁ ম্যাম আছি।
আচ্ছা, তোমাদের কিছু কোশ্চেন নেই?
না ম্যাম এখন তো কিছু মাথায় আসছে না।
আচ্ছা, ঠিক আছে।
ম্যাম
হ্যাঁ,
ম্যাম লাইট আউটপুট বলতে ওই এলওআর যেটা বললেন ওটা কি লুমিনাস ফ্লাক্স নাকি ক্যান্ডেল পাওয়ার?
luminous flux.
আচ্ছা,
Light output মানে luminous flux.
তো লুমিনাস, আচ্ছা ঠিক আছে কিছু
কি বলো?
না, ক্যান্ডেল পাওয়ারের সাথে যদি আমি ওমেগা মাল্টিপ্লিকেশন করি তাহলেই তো এখানে লুমেন চলে
তাহলে
আসছে।
লুমেন পাবে। হ্যাঁ, হ্যাঁ।
মানে ইনডাইরেক্টলি ভাবে তো, মানে যখন আমরা কোনো একটা ল্যাম্পের ওটা ক্যালকুলেশন করব তখন তো ল্যাম্পের লুমিনাস ফ্লাক্স আমরা পাবো না ডাইরেক্টলি, মানে মানে দোকানে কিনতে গেলে বা কিছু ওইরকম বলছি, তখন তো
হ্যাঁ,
আমি
দোকানে কিনতে গেলে লেখা থাকবে।
সিপি দিয়ে বোঝাবে তাই না?
হ্যাঁ,
তাহলে
সিপি দিলে কি হচ্ছে ক্যান্ডেল পাওয়ার, বাট সেটা ইউনিফর্মলি, মানে ক্যান্ডেল তো ডিরেকশনের উপর ডিপেন্ড করে বা ল্যাম্পের শেপের উপর ডিপেন্ড করছে না কোন দিকে কি রকম ইন্টেন্সিটি হবে। বাট তুমি যদি টোটাল লাইট আউটপুট বলো, সো দ্যাট ইজ দ্য প্রপার্টি অফ দ্য ল্যাম্প।
আচ্ছা ঠিক আছে।
ঠিক আছে, তুমি যদি ল্যাম্পের স্পেসিফিকেশন দেখো সেখানে ওই ওয়াট অ্যাম্পিয়ারের সাথে টোটাল লুমেনটাও দেওয়া থাকে।
হ্যাঁ ম্যাম।
ওকে, so next is the photometry. Photometry means measurement of the lighting parameters. So it is required for quantification of those parameters, and it allows to compare light sources and spatial distribution of light. So photometry can be classified as visual photometry and physical photometry. Like for electrical measurement, we always use any kind of instrument, right? Voltmeter, ammeter, like that. But here, the photometry can be either visual photometry or physical photometry. So visual photometry means observer-based measurement, which depends on the human eye. But physical photometry, this is detector based. Detector based means the detector's response or the sensor response is equivalent to the human eye. Because আমি সবসময় সেম নাও দেখতে পারি, আমি যেরকম দেখবো আরেকজন সেম নাও দেখতে পারে, so that is not accurate, right? So previously the visual photometry was used, but then all the photometry are actually the physical photometry, detector based or sensor based, where the sensor response is same as the human eye response. Okay. আচ্ছা, আমি এগুলো নেক্সট দিন ডিসকাস করবো। আমার ওয়াইফাইটা প্রবলেম হচ্ছে, প্রচুর বারবার ডিসকানেক্ট হয়ে যাচ্ছে। সো ইফ ইউ হ্যাভ এনি কোয়েশ্চেন আফটার দিস ইউ ক্যান আস্ক। কি বাকিরা কেউ?
ওকে ম্যাম।
হ্যাঁ, হ্যালো, কে বলছিলে? So in photometry, we have few instruments for discussion like lux meter, integrating sphere, and goniopotometer. So we'll discuss this one by one. So if you don't have any question, then I'll close for today. If you have any, then you can ask. Yes or no?
নো প্রবলেম।
আচ্ছা, তাহলে আমি আজকে ক্লোজ করছি। হ্যাঁ, নেক্সট মানডে আছে তো না?